Hello Sting Nation. Today's video will look at 3 examples for solving equations with variables on both sides. In this first equation we have 5x plus 6 equals 3 times the quantity 5x minus 4 minus 4x. As you have seen in a previous video, there are 7 questions that we ask ourselves when we are working on solving equations, and the first one of those questions is, do I need to clear fractions? As we can see, there are no fractions, so we can move on to the second question. Do I need to simplify one or both sides of the equation? As you can see, the left-hand side of the equation has no like terms, so it is already simplified. So we will be working on the right-hand side of the equation. We can apply the distributive property by taking this 3 and distributing it to the 5x as well as to the negative 4, and then subtracting the 4x. When we apply this, we end up with 5x plus 6 on the left-hand side. And then we have 3 times 5x and 3 times negative 4, and we bring down the 4x. On the left-hand side, of course, things are already simplified, but on the right-hand side, we still need to combine the like terms of 15x and negative 4x. So we end up with 5x plus 6 equals 15x minus 4x is 11x minus 12. So now that both sides have been simplified, we can move on to the third question, which is the variable on both sides? Yes, it is, and that is not what we need because we are looking to isolate the variable, so we need it to be just on one side. So what we do is we look at the variable terms on either side and see who is smaller. The 5x is smaller, so that is the one that we're going to get rid of using subtraction. Because this is positive, we need a negative, or because this is addition, we would need subtraction. And to maintain balance in any equation, what you do to one side, you also do to the other side. Now this 5x and negative 5x are opposites, so they are a 0 pair. So that has been eliminated on the left-hand side, and we're left with 6 equals 11 minus 5 is 6, so we have 6x minus 12. So now we have the variable on just one side of the equation, and we look to see if there's anything next to the variable. And the variable has a 6 being multiplied by it. It also has this subtract 12. So from there, we need to figure out what we need to do next, which is adding or subtracting. If I add or subtract, would that help to isolate this variable? And since we have this subtract 12, to get rid of that, I can add 12 to both sides. This being a 0 pair, so they just make 0. 6 and 12 on the left-hand side make 18, and that equals our 6x. And then the next question, do I need to multiply or divide to isolate that variable? Yes, I need to get rid of that 6. Since it is being multiplied, I'm going to do the inverse operation of division and divide both sides by exactly what is in front of the x, which is a 6. And we have a 6 in the numerator, a 6 in the denominator. Those divide to make 1. And so 18 divided by 6 gives us 3 and 1x. So now we have indeed isolated the variable, and we box our final answer. So x equals 3 or 3 equals x. So that was our first example. Our second example is 3/5 f plus 24 equals 4 minus 1/5 f. And this is actually a case where we're going to get to clear fractions. So, do I need to clear them? Yes, I do. So to do that, we look at the denominator. This denominator is 5, so is this one, so that's going to make our life a little bit easier. We are going to multiply through by 5. We're going to multiply every single term on both sides of the equation by 5. So if I take 3 over 5 and multiply it by 5, these 5's will cancel, and that is going to leave 3 f. 5 times 24 gives me 120. 5 times 4 gives me 20. And 5 times negative 1 over 5f will give me negative f. So, by multiplying through by the common denominator, which in this case is 5, we can turn those fractions into whole numbers. Now we look at number 2, question 2. Do I need to simplify one or both sides of the equation? No, because they are already simplified. Then we look to see, is the variable on both sides, and in this case it is. So again, we compare the variables terms on both sides. We have a positive 3 and a negative 1. The negative 1 is smaller, so that is the one we're going to get rid of. So we're going to add f to both sides. Well, I just made a mistake, so we are going to wipe that out. And rewrite that f. So we are adding f to both sides. Over here, opposites do make a 0 pair, so those 0 out on the right-hand side. 3 plus 1 gives us 4f plus 120 equals 20. And that brings us to, is the variable on both sides? No, not anymore. We have it isolated over here. However, there is something next to the variable. We have multiplication and addition. Since we do have something next to the variable, can I add or subtract to get rid of one of those? And yes, I can. I can subtract that 120 to get it off of that same side that the variable is on. So, I'm going to subtract 120 from both sides. Again, we have a 0 pair, a positive and a negative 120 make 0. So we end up with 4f equals negative 100. So we still don't have the f completely by itself. It's being multiplied by 4. So do I need to multiply or divide to get rid of that 4? Indeed I do. Since that's multiplication, I need to divide both sides by 4. And we use a fraction bar to show that division. 4 divided by 4 is 1. So we end up with f equals negative 25, because negative 100 divided by a positive 4 is going to give you a negative 25. Our final example is going to be 3 times the quantity 3m minus 2 equals 2 times the quantity 3m plus 3. Again, we go through our questions. Do I need to clear fractions? No, there are no fractions to clear. Do I need to simplify one or both sides of the equation? Yes, I do. I need to apply the distributive property to both sides. I show that by using arrows. So I have the 3 distributed to both the 3m and to the negative 2 on the left-hand side of the equation. On the right-hand side of the equation, I have 2 distributed to 3m and the 2 distributed to the positive 3. So once I apply that distribution, I do 3 times 3m, which is 9m. 3 times negative 2 is negative 6. On the right-hand side, 2 times 3m is 6m, and 2 times a positive 3 is positive 6. Both of these are now simplified, and we move on to the next question, which is the variable on both sides? The variable is indeed on both sides, so what we need to do is compare them and see who is smaller, and the 6m is smaller. It's a positive 6m, so to get rid of it, I need a minus 6m or negative 6m. And again, what you do to one side, you do to the other. These make a 0 pair. So simplifying on the left-hand side, 9m minus 6m is 3m minus 6 equals 6. Is there anything next to the variable? There is indeed. There's a multiplication by 3 and a subtraction of 6. Can I add or subtract to get rid of one of these two numbers? Yes. If I, since there's a subtract 6 here, if I add 6 to both sides, then this pair will 0 out, leaving the 3m. and 6 plus 6 is 12. The next question, do I need to multiply or divide? Since this is multiplication, I can divide both sides by 3, and I end up with these canceling to make a 1, so I have m equals 4. And that one is solved. In every single case that we had today, the answer to question 7 is no. Did I multiply or divide by a negative number? I did not multiply or divide by a negative number, so that was something that we will be taking up in a later video. Thank you for your attention.